Hello and welcome everybody to this special live stream today that we're hosting to show you how you can upgrade to the latest version of Prisma, Prisma 4.0 that we have just released last week. My name is Nicholas Berg. I'm the head of developer advocacy over here at Prisma, and I'm with three colleagues today. Why don't you quickly introduce yourselves? And Tom, why don't you get started?
Yeah, hi everyone, I'm Tom. I'm on the schema team and engineer at Prisma, so I work mostly on the open source where I'm implementing stuff.
All right, and you're working mostly on the Rust layer, or are you also involved with JavaScript or TypeScript?
Mostly Rust. I try to do both.
All right, so all the engine internals, that's our expert here today. Yeah. Then we have Frederick.
Yes, hello everyone. My name is Frederick. I'm a product manager at Prisma with the schema team. So Tom's team. Yeah, we deal with all parts of the Prisma product that touch the schema. So introspection, migrations, our IDE integrations, and the CLI.
Yes, and then we have another product manager here on the team, and that is Matt joining us from the US, I think, right?
Yep, from Chicago. Hey, everybody. I'm Matt, and I'm the product manager for the Prisma Client, and we are responsible for reading and writing data to and from databases. It's a bit of a mouthful.
All right. And a quick side note, Matt, your connection has been cutting out a few times. I'm not sure if you can change anything, but your part is also in the end, so you still have a bit of time to figure it out, I guess. Because we're going to start this upgrade process with a little bit of an intro from Frederick, who I think prepared some slides for us to explain kind of the overall upgrade process, because the changes that we introduced last week, there were a bunch of breaking changes, but actually not everybody who has been using Prisma 3 will run into these breaking changes. So depending on which kind of features you have been using, you might actually encounter these breaking changes or not. In the ideal case, you can just upgrade to 4.0 and you won't see any problems. But if you're using specific features that we needed to break in this major version release, then you might be interested in how you can resolve the issues. And I think that's what Frederick has prepared for us. So you can share your screen, Frederick, right here. And yeah, maybe walk us through on a high level of what that upgrade process actually looks like.
Yeah. Okay, thanks, Nico. So yeah, feel free to interrupt me as you please. It's, I think, roughly 30 slides, and I don't want to be too boring here, right? So as Nico just said, the TLDR really is, don't worry. I know the release notes for Prisma 4 and also the upgrade guides we have released in the docs, they might have looked a bit intimidating because it's a long list of things and it might look like, oh my God, how do I upgrade? But I think perspective is important. And so most of these changes are either edge cases. So the majority of our users shouldn't be impacted, or very easy to fix. So don't worry, even though the list of potentially breaking things looks long, in reality, we believe it should be very, very easy to upgrade. And yeah, and in this session, Matt and me are going to show how that's done, not for all of those, but we show the general upgrade use cases. And then you can apply that to other things as well.
Nice.
So in general, we have a recommendation how to go about these upgrades. There's an order of steps that make the most sense. And it's actually fairly straightforward. There's like these 3 steps that we see. First of all, there can be validation changes. And in this case, there is. So Prisma 4 introduces a bunch of more consistent and more tight validation rules. And so fixing those is usually step 1, because you need a valid schema so you can, for example, generate Prisma Client or run migrations and so on and so forth. So validation, fixing validation errors is step 1.
Okay, so with validation rules, Frederick, you mean these red squiggly lines that might appear in the Prisma schema. So if I just upgrade to Prisma 4 and all of a sudden I see I have red squiggly lines in my Prisma schema that weren't there before, it's because I'm violating some of the newly introduced validation rules.
Yes, exactly. There's a second way to surface those, which is in the CLI with Prisma Validate. I'm not so sure if we have fully documented that command, but I'm going to demo it, and we're also going to add it to our documentation. That's something I stumbled upon that so far this has been not documented, but it's fairly handy. So you can just run the validator on any schema, and it gives you output on what's not valid. But yeah, as you said, in VS Code, it's very similar, and I'm going to show both approaches.
Got it.
That's step one. Step two is adopting new, I'd say, schema capabilities. So it's important to understand that we use an abstraction on top of the database, and that always means we don't have like a fully clear picture on the reality of the schema in a database. And to the, like, basically what we understand, what we abstract is also only what we touch. And that means if we introduce new capabilities to Prisma schema, so our abstraction gets more sophisticated, that sometimes has implications on how to kind of migrate that into your project. And that's what I'm going to show in step two. And then step three is what Matt is going to do. Matt is going to do a live demo on Prisma Client and how to mitigate some of the changes that are coming with Prisma 4. Okay, let's dive right into it. So validation changes. Why have we chosen to implement those? It's mainly for consistency reasons. So we want Prisma schema to be consistent across database connectors, at least to a certain extent. We know that's not really possible, right? You can't just expect to work with Prisma with Postgres and then move to MongoDB and everything is exactly the same. That's not possible because the databases under the hood are so fundamentally different. But in general, if a database imposes a certain, let's say, design approach or design pattern, then we want to embrace that also in Prisma schema. And there were a few consistencies around these examples that we had, for example, for Postgres, but then not for MySQL and so on and so forth. And so we wanted to make that more consistent across the board. Second area is implicit and explicit behavior, meaning sometimes we don't explicitly show a certain behavior in Prisma schema, but under the hood, this is how we treat the database schema. And so we have chosen in some cases to make these implicit behaviors now explicit in the Prisma schema. So it's really straightforward to see what's happening, and it's easier for users to understand what's going on. And then lastly, obviously fixing a bunch of bugs. Nico, yeah?
Yeah, so these kinds of like implicit behaviors would be probably what some developers would refer to as magic, when things just happen under the hood and you don't really know why, and you can make those explicit by just like introducing them like in the schema actually. And that's one shift that we have been doing with the Prisma schema to move towards this more explicit approach, where you actually look at the Prisma schema and you understand the structure of the underlying database in a bit more detail.
Yeah, that's exactly right. I would maybe not use the term magic, more like surprises. I personally, I think we should avoid surprises as good as we can. And this is one of the measures that we take to reduce the amount of surprises, but also maybe magic. Well, I would argue I want to increase the magic, but that starts again. And then lastly, fixing bugs. There were a few things we wanted to fix. We piled them up because they're technically breaking changes, and so this is the last reason why we tightened the validation in Prisma schema a little bit. Okay. Let's dive into the examples. And as I said, there's more changes in the changelog, but the character of these changes is very similar, so I'm not going to run through all of them. First of all, I just mentioned it, implicit versus explicit. So here in these one-on-one relationships in Prisma 3, basically the foreign key didn't need to be unique. This wasn't enforced explicitly in Prisma schema, but implicitly, this is what happened under the hood anyway. And so with Prisma 4, we now enforce a unique constraint on these foreign keys. And yeah, it's, as I said, one of these examples where what's happening anyway, we now just make explicit in Prisma schema. The next example is around, and this is now a bit confusing in terms of terminology. Prisma has two ways to manage many-to-many relationships, an explicit and an implicit way. And the difference is that the implicit way doesn't model the join table in Prisma schema. So here in between, kind of invisible, sits a join table between these two, and it's not visible here, so it's kind of not modeled, and that's why it's an implicit relationship. And Prisma managed that relationship for you. That table is managed for you, and it's fairly strict what it allows. And so in these relations here, there is a few configuration options that don't apply to implicit many-to-many relationships, because we don't allow, for example, to set anything else than the ID field here, the primary key. And so because, showing these options, but then don't allow to change them, we decided to remove that. And so in Prisma 4, you can't set the references argument anymore on implicit many-to-many relationships. Again, I think pretty straightforward. The next one, I think, is even more edge casey. It's around one-to-one and one-to-many relationships for MySQL, where in certain situations, users have been using non-primary keys. So now it's important to understand we are on the other side of the relationship, right? So here's the relationship defined, but we're not talking about here the foreign key, but now we talk kind of about the key that we reference. And in some cases, users have been chosen here not to use the primary key, the ID field here, but instead a non-unique, non-constrained field. And from now on, we enforce that for MySQL to also be unique or an add ID field, which, by the way, has been the behavior for other database connectors already. This was an odd kind of different behavior we just had for MySQL, where we decided to align that behavior.
One quick question of clarification here. So is it actually possible in MySQL to define a foreign key that's neither unique nor a primary key? Was that valid before?
The foreign key is unique already.
Right.
The other side of the relationship. So the foreign key is unique. Mm-hmm. But here we now also enforce that this one here, this is a one-to-one relationship, that this field here also has to be unique. Otherwise, it doesn't make really sense for this relationship.
Exactly. But this was not was that represented in the underlying database before, that there was a unique before if people used this approach? Or is it just possible that this wouldn't have to be unique if you were just using MySQL?
So the difference between this one and the previous one was that the previous one, Prisma, was implicitly understanding your schema as there is a at unique, and then it would put the at unique in the database. In this one, it's something that's valid on MySQL, where you can create that without a unique, but it doesn't really match how you think about foreign keys, and that's a really weird construct. So it was without a unique in the database. And it can still exist in the database, but we don't allow it anymore because the relation doesn't work like you would expect. If you have a profile with a user email, you expect to have one user on the other side, and that's also what the types in the client will reflect. But in this database, you could have multiple ones, because nothing prevents in the database multiple users from having the same email.
Okay, so in a way, we're even fixing some weird behavior of MySQL here by actually constraining it in a way that makes sense.
Yes.
Nice.
Yeah, I think to be fair, it's an edge case as well. We have discussed this quite intensively internally, kind of with a change proposal to the Prisma schema. Do we all agree this is a good idea, and this is what we came up with?
Great.
Okay, so now this is enforced. And the last one is not really a validation. I mean, at least I didn't come up with a good example here, but what we did is really tighten the validation of strings. And to be really honest, it was a bit messy in Prisma 3 how we treated strings. And one example is here, Unicode escape sequences weren't supported because somehow our code stumbled upon the backslash and the U and thought that's a no-go string. And there were a few really not beautiful edge cases around that, where also the whole life cycle around strings, so basically how we interpret strings from the database and then write them into Prisma schema, or the other way around, so interpreting Prisma schema and then writing the string back to the database, could yield some weird side effects. And what we've done is we adopted the JSON specification for strings. And so from Prisma 4 on, any string that's valid in JSON is now also valid in Prisma schema. And for example, it also then allows you to use these Unicode escape sequences and have a pretty straightforward, like the whole cycle now is kind of using the same rules. And there shouldn't be any side effects anymore when you move strings with, especially around escape sequences and escape characters from schema to database and back. So here you have a valid euro sign now in this example. All right, so now let's dive quickly into VS Code and show how this would be done in practice. So here in this project, and it's also on GitHub, so I can share the link to that later on. It's a very simple Prisma project, doesn't have any code, it's just around the schema. A few things, I have 2 subfolders, which each have different versions of the Prisma CLI, so I can demo how validation behaves with these 2 different versions without reinstalling. And then in the Prisma folder, I have the main schema, and then I have these kind of templates here, 1, 2, 3, 4, for my steps that I'm going to show, which record the different states of the schema when I'm evolving it over time. So now the start state is here this step 1 file, which I copied here over. And you can already see now I have the Prisma extension installed already, the number 4, like version 4. So here you see I have version 4. And maybe just for demo purposes, I can go back to the old version. I reload VS Code. And now this schema is perfectly valid. Prisma 3 likes the way this schema is written. And now what we can do, we can jump into these subfolders and kind of use Prisma 4 to run npx Prisma validate. Is it Prisma migrate validate?
Just Prisma validate.
The StreamYard controls.
Yeah. Schema.prisma, and I'm using this flag to use a schema that is located somewhere else, right? I'm CDing out of that folder, and so now Prisma 4 gives me these validation errors that obviously I wouldn't see with the Prisma 3 CLI. So just to prove my point, let's copy this over here into Prisma, in my Prisma 3 folder, and in Prisma 3 the schema is valid. And now let's do the same for the VS Code extension. So I'm now upgrading to Prisma 4. I'm reloading. And we go back to the file. And now we see this. What do you say for that, Nico? Squiggly lines?
Red squiggly lines, yeah, indeed.
Red squiggly lines. Okay, and it's actually pretty nice what we have here in terms of the X. So there's a nice tooltip which exactly tells me what to do. This is a many-to-many, it's implicit, and this relation should not have the reference argument defined. Either remove it or change the relationship to one-to-many. That's what I obviously don't want to do because it is a many-to-many relationship. So I'm just stripping this stuff here. The same goes for the other side. Again, I get this nice hint, and I can save it. And now I have fixed the many-to-many relationship already. And then the last one is here on my one-to-one relationship between profile and user. And again, I have a error parsing attribute. A one-to-one relationship must use unique fields on the defining side, either add unique or change the relationship type. I don't want to change the relationship type. So instead, I'm adding add unique here and save. And now, et voila, the file is valid. And we can quickly also validate this on the CLI. And that's basically it. And as I said, I think most of these validation errors should be in the edge case land. And you have just seen how easy that is. So basically, you can even do that without touching your installation, install the CLI version 4 into a subfolder and try that to get going. I think it should be fairly easy and straightforward to do that. All right, back to the slides. So yeah, this is the schema that I looked at, and this is what I just showed you in live. So I'm going to skip through those. Left, invalid, right, valid. Now comes the interesting part. I wanted to quickly, I know you guys have demoed this in What's New in Prisma a few times, but we have this tool called migrate diff. which is really handy in these situations. And diff is a CLI command that allows you to diff any state of a schema that Prisma understands. And we have these kind of 3 representations of database schema state in Prisma: the Prisma schema file, the actual database schema, and then our migration history. And you can use migrate diff to get the difference between any of these 3. And there's actually a 4th option, which is empty. So you can also use it to get the diff from empty to any of these 3 representations. And that's super handy. And this is how the command is used. You say migrate diff, and then you say, okay, this is my start schema, and this is my end schema. And then I'm using this option here, script. So it gives me a SQL script as output. And that SQL script could then be applied to my from, and then the end result would be my to schema. So it's super handy to find out what's the difference here. And what I'm doing now, because I have technically changed my Prisma schema, right? I have removed things, I have added things. It might be a good idea to just verify that this still represents 100% of Prisma's understanding of the schema in the database. And so what I'm doing here is I'm using diff, and I'm diffing from the data source, which is the URL of our database, to my Prisma schema file. And if the output of that, this is an empty migration, that means there is no mismatch between the 2, and that's exactly what I want here. And I think what I also really like about using migrate diff here is it doesn't change anything, right? There's no change implied by using migrate diff. You can then pipe this output to other commands and then actually do stuff with it. But for now, it's just a reporting tool, so it's super safe to use, and you can use it to help you along these migration paths. All right, and that's it. You have updated your validation to Prisma 4. And I hope that was easy and understandable. Do you guys have any questions, or should I go on with the next topics?
You can move on, but I would have been curious actually if you could maybe just show running the migrate diff command.
Yes, I'll do that. I'll do that in a second, because okay. I need it for the rest of the demo as well, and I'm gonna show you.
Okay, perfect.
Okay, so now the second part is not about validation, but adopting new Prisma schema capabilities. And that is important because I tried to explain it in the beginning. The Prisma schema is an abstraction, and we try to only touch aspects of your database schema that we understand. Anything we don't understand, Prisma tries to ignore. And that's totally fine, right? It's an abstraction. But now if we introduce new features to Prisma schema, suddenly Prisma understands new stuff, new capabilities, more advanced features of your database. And that means you should then also reflect those in your Prisma schema, because if you don't, and you would migrate or DB push, Prisma thinks what you actually want in your database schema is what you have in your Prisma schema and not what you have in your database schema. And so for that, I'm gonna show you a quick demo. How that's done is also fairly easy, but it's the safe path to adopting these new capabilities, I'd say. So the first feature is defaults for lists. So we call them sometimes scalar lists. They are arrays, and so far we didn't support any defaults for those. So here in my schema, I have these there's a roles array here which uses an enum, and I can't set any defaults here, so there is no default role possible, and other stupid stuff like colors or numbers. And so now step 1 is actually I want to check if I have configured these defaults in the database, because Prisma didn't support it, but I rely on them. So I might have made the decision, okay, I will stop using Prisma Migrate because I need these defaults. And so while I want to adopt those, it's important to see if I have actually those already in the database. And so for demo purposes, what I have done, I have pushed the end state of me adopting these defaults to the database already before this demo. So I've just used db push to actually set these default values in the database. So they are now in the database, but they are not reflected in Prisma schema. And so what I'm going to do
and to be
now,
clear, like people could have done that themselves on Prisma 3. If they wanted to have default values for arrays, then they could have customized their own migrations and configured these default values just in the SQL migrations. And then they would have been present in the underlying database, but not in the Prisma schema. And now what you're doing is you're surfacing these also inside of the Prisma schema, basically. Or actually, like for now, you just compare your Prisma schema with the database to see, okay, what's the difference? And you'll see that inside of the database, you'll have default values that are currently not represented in the Prisma schema.
yes, that's a super accurate summary. So if I would run now this diff with Prisma 3, it would be empty because Prisma 3 doesn't understand these defaults. But with Prisma 4, these defaults would now appear because they are understood. And so if I now issue here migrate diff, and my from state is my database schema, and my to state is my data model in the schema, which is what you see here. And the output is a script file. So if we run this, I think I have screwed up my paths again. Oh yeah, sorry, I'm in the wrong folder. So it should be this folder. npx prisma migrate diff from schema data source to schema data model. Yeah, that's what I want. And the output is the same output you would usually have in a migration file. So this is the SQL that you would need to run on your database to get the state that is today in your Prisma schema, right? So here, roles, favorite colors, lucky numbers don't have any default values. And so I would need to drop these defaults now. And so this would be a warning. Okay, there is something in the database that is not in Prisma schema, and you would now need to handle that. And the easiest way to do that is db pull. So I'm now pulling from the database. So I'm using our introspection capabilities to check what is in the database and write it into my Prisma schema. Demo gods, let's hope this works. And bam, here you see now these defaults written into the Prisma schema from the database. And so now they should be in sync. So if I run the same command, now the diff should be empty.
Awesome.
All right, back to the slides. So I have done that. In most cases, I assume users don't have these defaults. And so it's very safe to just adopt them, add them to your schema, and then go on and migrate. And that's what I've also done here in my migration folder that I'm going to share in this Git repo. So this is the migration that then adds these defaults to the database because they are now present in Prisma schema. Okie dokie. Okay, and the next kind of big capability that we shipped is around the configuration for indexes. And yeah, there was a preview feature called extended indexes that we have been growing over the last few months, and we have constantly added new index configuration capabilities to that feature. And there is a bunch, so please refer to the docs for an overview. And I think, Nico, you have already talked through some of them in What's New in Prisma. But the one I'm going to demo here is, imagine you use a Slack on blog posts to actually look up the blog post. So imagine you have your application and it renders a URL, and you have this URL fragment, and you need to use this URL fragment now to look up your post, to find your post. And that is not a key, so there's no constraint on that normally. And then you would normally want to set an index for that. And so this would be the default that you would have done in Prisma in the past. And now we support different types of indexes for Postgres. And so for these kind of equality lookup operations, the fastest you can go is using a hash index. And so I'm not going to show this now again, but basically to be safe, again, with Prisma 4, what you would do is you look at your database and you diff what is in the database and what is in your data model. Is there index configuration that you don't yet have in your data model? So I again would recommend to use migrate diff to check that. And then you can start adopting, for example, this type configuration here that allows you to set like gin or gist indexes or hash. But hash makes a lot of sense for these Slug examples because it should be the most performant index for querying like individual posts based on the Slug, which is I think a fairly common use case for web applications these days. Is that clear? Seems so. And then afterwards, you would persist that new index into your database using migrate. So this is then the migration that comes out of migrate. So let's go back into here my folder, and this is the last migration that I prepared, which is this one that then adds the hash index to our database. All right, and I think that's basically it. And unless you have more questions, I would then ask Matt to take over and run us through the changes in Prisma Client.
All right, that was very clear from my side. Thanks a lot, Frederick. We don't have any questions in the chat so far, so I think we can move on to Matt indeed. And this is also an encouragement to everybody who's watching right now. If you have any questions about the upgrade process to Prisma 4, then now is the time to drop them in the chat so that we can pick them up at the end of today's episode. All right, Matt, are you ready to share your screen?
Yes, I am. Hey, everybody. Yeah, I'll be kind of walking through some of the changes we made in the Prisma client. And I want to reiterate kind of what Frederick said in the beginning. Don't worry, they're not that big of changes. And we made them for good reasons too. So yeah, with that said, I will share my screen here. Okay. I don't have slides, but I'll be sharing kind of the TLD, or I'll be doing a demo version of what you see in the release notes.
Perfect.
So okay. One of the big things that we changed for the Prisma client was this improved query raw preview feature now just became the default way of doing query raw. And with that came a couple of changes. We basically tightened up the types that like what you pass in as inputs is now a bit tighter than it used to be, and that fixed a whole bunch of bugs. And so let me show you kind of how that, like an example of this failing and how to fix that in code. So in 3x, you could do something like this: select length, and then you could pass in a number here. And just for a bit of context, length in SQL like expresses a string essentially. And so what's happening here is like we're coercing a number into a string and passing that through query raw. And in 3.x, this worked as expected. You would get a length back. It's actually taking this 42 and turning it into this, and then taking the length on that, which is a bit unexpected too, I would say, but it kind of makes sense in some way. So in 4, we actually let me go to 4 here. I just have these in separate repositories. So this is 4, and let's see here. So now if I do this same thing in 4, oh, I need to actually, oh yeah, okay, this is right. So now it's saying, now it's actually throwing an error saying length big int does not exist because it's like, if this were a function in the database, this would work, but this isn't a function in the database. Remember, it's length string. And so to fix that, you basically just need to manually coerce your values that you pass in. So like to fix that, you would say, hey, turn this number into a text that can be used by the length command. And so That's one example. There may be some other ones. What I would recommend for Prisma 4 is basically just run through your query raws, make sure they're tested in your code, and just double check that like the values you pass in match what the values that the SQL databases expect. And this is just for the SQL databases. This doesn't apply to Mongo at all. So that's query raw. I don't know if there's any questions on that one.
No questions in the chat so far. And according to my understanding, this also like caters a little bit to that theme of making behavior more explicit, where before we kind of implicitly took this value and coerced this to a string ourselves. Now this is basically on the developer to make sure that the values that they're passing in have the right type for that particular function in this case.
That's exactly right. And with that, like it's you can see it as being a bit more strict, but also fixes a bunch of like long-standing bugs that we've had with query raw. And so by being more strict, we also fix a bunch of issues that may surprise you, like may have surprised you in 3.0. So. Cool. So I will move on to the next thing, assuming there are no more questions. Yeah, so, okay, let me do this one. Let me do this one first, actually. So in 3.x, or sorry, in 4.0 and beyond, we are deprecating this reject on not found. It was always kind of a weird child, like it didn't have type safety. Like it did. Maybe I'll explain what this actually does first. What this does is it will throw or reject, like basically throw an error or rejection in a promise if this find unique on this user was not found. Actually, it calls this function, and in this function I'm just throwing. And so what this allowed you to do was, if I ran like ts node index here, it's going to throw an error. So like, let me just double like verify that here. Like you shouldn't see that high basically. Yeah. So it threw this error, and that where this throwing happened way up here. And I'm going to be honest, this is a convenient API, but at the same time, like there was no sense of type safety here. Like if there was no way for us to actually, user is declared, do I actually get a full user here? Interesting. We might have actually made that work. So I think there may have been something in here that was like, okay, we're like, usually this would be like user or null basically, and we may have found some way to make that part work. But in general, there are a bunch of open issues around like this not flowing through. And so this still works in 4. Like you can do this, but it's deprecated, and we'll probably remove it in Prisma 5. And so the way to fix that, oh, let me actually show you before I jump to 4. Another way, a common way of using reject on not found was inside the, as a second option to find first or find unique, was you could kind of set this reject on not found in here, and it would do kind of the same thing. So yep, throws an error. Again, this one is also rejected. Is deprecated. All of the reject on not found are deprecated, and so we suggest you to move to the new syntax. And what is the new syntax for 4.x? It is using something called find first or throw. And so we're no longer, because we learned our lesson about the type safety, we've deprecated these two things, reject on not found up here. And so what you'll need to do for your code base is, if you do have this reject on not found up here, you'll need to kind of propagate it through your queries and change those queries to either find first or throw, or the other one is find unique or throw. And the benefit of this is it's more localized. You can see what's going on. You're not changing behavior globally. And it also is more type safe. Like it fixes a bunch of the type safety issues.
From a high-level use case perspective, Matt, when would I want a query to throw instead of just returning an empty result? Is that for queries where there should be something, but there's not, so this is a problem? Is that what is this about?
Oh, that's a good question. Yeah, so imagine like scripts or things that you don't really care, like you don't want to have to do like, let me do this, cons user and like this. So now we've got user or null here. So like if in most cases you just want to use this normal one, but like if you just use the normal one, like you needed to be like, oh, the user is not found here, and then have a new path here. And in some cases you don't actually care. Like you just want to be done. Like if this doesn't succeed, you cannot proceed with your computation, and you just want to fail earlier. And so I like find unique or throw in scripts, or I like it in places like maybe Express or Koa, where there is some sort of like wrapping around your request response handlers that like handles throws for you basically in a kind of an elegant way. And so like I can speak for Express, where like if you hit at a throw or like an uncaught error or something, like it would pass through the middleware stack and you'd be able to catch it later on. And so if you cannot proceed if the user's not found, for example, if I cannot do anything down here, sometimes like you'll clean up the API a little bit by like just having find, unique, or throw.
Okay, makes sense. Thank you.
Yeah, I still kind of like being explicit about this, but you do get to remove some of these checks. So, yep. That is that. And then let's see, what is I've got a couple more here. Oh, okay, this one. This one you probably didn't run into, but I just want to kind of show you. It's honestly kind of like a little bit silly on our part. So we had, let me just open up oops. All right. So there's this thing called DB null and Prisma null or JSON null actually for JSON fields. And so let me go to my schema quickly to show you what I mean. I've got this optional JSON field in this user. This is under the meta field. And if it's optional, that means it can be JSON or null. Now, the problem with SQL databases is you can have a null in the database and you can have a null in JSON. And so how do you actually differentiate between these two nulls? Well, we came up with this, I don't know, it's kind of a hack, I would say, but like we came up with a way to differentiate between them because our users needed to be able to differentiate between them. Some of them had null in here, and some of them had null, and some of them wanted to query or filter on that, and then some of them had database null, and some people wanted to filter and query on that. So we needed to come up with a way of differentiating between these two nulls. And so the solution we came up with was you have this Prisma DB null or JSON null or any null if you don't care. And so you could do this like where you would do Prisma DB null, and I would be like, okay, oops, I'm in 4.x right now. Let me change back to 3. JS node index. Okay, and so I've created that user, and let me open this up here, and okay, let me just delete this one.
Okay, so with DB null, you now expect that there is no value in the meta column. So the optional, that's right. Like the optional kicked in here, and it's actually not a value. Yes, exactly. So we passed in the null to this meta column, basically, a DB null, a database null. If I did JSON null, let me just show you for demo purposes. Like we get this null here, and this is a JSON null. All right, and that's because the problematic beforehand was that this null keyword is valid JSON. So it is now storing valid JSON in that column, but it's now there.
Yes. This isn't the problem though. So the problem in 3.x is we used a constant string here. And with TypeScript, that means I can just do this. And let me change this to one more person. And you'll see a null just like before, but then I think the kind of funny one is this one, where it's again just a string, but it's like a special string that, like, if I pass this string in here, I get a null here, which is surprising to say the least. Now, I don't think that many people ran into this. It's kind of just more like, whoops, our bad. And so in 4.0, you can't actually pass the string in there. We've kind of tightened what is allowed here. So let me show you what I mean by that. All right, but I'm now in this one, and it's kind of the same. Let me change this to another name here. And so the same behavior works if you've been using it like we've documented it and everything like that. It's only if you kind of, oops, let me get rid of this so it's not so confusing. I still inserted it here, and that's null here. The thing that we've prevented now is like, you shouldn't be able to do this. Yeah, okay. I would have expected a type error there. Let me just try this. Oops.
Would you expect a type error?
No,
because
you're
it's
right.
still valid JSON, right? It's just a string, so it's also still valid JSON, which you can pass.
Great point. Yep. And that is exactly right. So what you see now is you see a string of DB null. And so that's a great point, Nico. Yeah, so this is valid JSON, so it's not going to show a type error. This is working as expected. Yeah, and so, oops, did I stop showing? I've got this like bar at the bottom. That's okay.
No, it's still there.
Okay, cool. So for you all, just do a quick check, like do a like a find replace on your DB null, or just like look around for this. Do a quick check in your database. Be like, or I guess no, you wouldn't be able to check in your database. Just I would just do a quick check to make sure that your DB nulls are passed through properly, basically. And if you were using this Prisma.db null the whole time, you have nothing to worry about. So yeah, that is that one. And then I've got two more to show. How are we doing on time, Nico? Are we doing okay?
We are not time constrained for this stream. We have as much time as you all need.
Okay, cool. Let me show you the SQLite one, and I'll show you one Mongo one then as well. So in SQLite, we fixed an issue with rounding big numbers. And let me go to this. Fixed rounding errors on big numbers. And so what could happen with SQLite is you've got a, let me ls here. So I've got a SQLite database here called my.db, and I'll do select all from user here. Whoops, from user, and I've got this like massive number in there. And with SQLite, you can kind of just put whatever you want. Like you can put large numbers into integers, basically. Let me show that actually. How do I tables call? I don't actually remember what I inserted. Actually, let me look at the Prisma schema here. So I have an age. Okay. So okay, let me show you what I'm talking about here. So insert into users user. It's been a while since I've written SQL values. All right, let me do age and then values, and then I can just like put a wild number in here. And if I do that, it's going to just work. Like, even though it's an integer, it's going to work. And so that's because SQLite is like loosely typed. There's no way to actually, I don't know how to introspect. Oh yeah, here we go. Okay, so dot schema, you'll see an integer, and in most databases like this will fail miserably, and it'll say, hey, that's way out of bounds. But in SQLite, anything goes. So that is a problem for us because we assume that, well, first of all, JavaScript I think is like 30 some bits. So like this isn't going to fit in a JavaScript number. So it's a problem for us. Also, it's kind of surprising that like this big number would be considered an int. And so what happens with SQLite, if you've had some big integers in there in 3.x, it would, let me go back to my index.ts here, and I'm now finding many on the users here. Let's see what happens. Oh, interesting. I think I may have put a even too big of a number for everything. So there might be some range. Let me just quickly delete from user user where ID equals 2. Let me try that. Okay, select all from user. Okay, now we're back at what we had before. And you take a note of this number here. It's like, it's got an 807 at the bottom or the back. And look what we get back. So what we get back is a rounded number. Like it rounded it from 5807 to 6000. That's a problem. That's very unexpected. And so in Prisma 4, we fixed that. Did I have an actual Prisma 4 with this? Okay, no, I'm just going to go ahead and upgrade this one then. I'll do an upgrade Prisma add 4 and add Prisma Client. Oops, add 4.
So now when you run the script again, then you expect that the actual number is going to be returned this time and not the wrong one?
I'm expecting an error because we can't actually fit this big number into JavaScript, basically.
Right.
So now I've got this error. Conversion value does not fit into an int column. Try migrating the age column to big int. So we've got a better error, basically. And if you did want to fix this, you could then put in age db dot big int, I thought. Actually, I think it's just like this. Yes, it's a native type. So then you can use this. All right, I'm going a bit off script. I'm not sure if this is going to work or not, but let me try. Okay. I wonder if is there a way to migrate this? The migration folks migrate a int to a big int without losing the data.
You could.
I guess not.
Okay.
I mean, wait, it's SQLite, so it's going to redefine the table, and when we redefine the table, we reinsert the data. So we do try.
Okay. Okay. Let me try that then. So I'm gonna say yes. Okay, all good, and let me try actually going back into this and saying select all from user. Oh yeah, nice. Okay, so it's still there. Cool. All right, let me try this then. This is awesome. So you can see at this n at the bottom of the back of this thing is showing that it's indicating that's a big int, and now it is. Let me just quickly show you again. From user, we've got the exact same value here and here. Cool, that worked surprisingly well.
Nice.
Awesome. Let me show you Mongo now. Now Mongo isn't exactly, I don't know. I think it's a slight breaking change, but I don't know if I'd classify it as that. It's more like a feature we added to make it consistent, or it's more like we fixed a bug. To make it more consistent with the rest of our offering. And so with Mongo, we had this thing where, let's go to schema here. There's this problem in Mongo where like there's no sense of there's no structure with Mongo. It's a NoSQL database and no schema, and so we kind of impose a schema on top, but that schema is not enforced at the database level. And so what happens is you are allowed to add fields here and make them required, and nothing in Mongo is going to stop you. The problem is with Prisma, we want to actually enforce a schema. We want to have guarantees about what's in your database and what the structure of your database is. So imagine this field's like we've added this later to users, and all the users prior to this point don't have this. Let me make it a little simpler. In age, all the users prior to this point don't have an age. And then all future users have an age. But say we want to find on users and this age is expected to be here. Well, if we do find on those users, it's going to throw an error because, hey, like age doesn't exist on this user, on those past users. So what we do to support those use cases is we allow defaults. And so a default is if the defaults will apply if you found on those old users and those users didn't show up, it will just automatically, as you're reading out, it's going to apply those defaults. And so what's nice about this is it kind of gives you a way to kind of incrementally migrate your Mongo database over time. Because like as you're pulling things out, you're kind of pulling out old values, but also the defaults that come along with the old values. And then when you do another write, you've now actually migrated kind of on demand. We're calling this on demand migrations. You've migrated while your application is running. And so that works great for models, but it didn't work at all for composite types. And so we actually just kind of missed this. And so let me show you actually what I mean here. So I've got this MongoDB database. It's on 3 here, and okay, I've got this create command here. So I'm going to create this initial user here, and they've got a email and a street. Now say, whoops, we forgot the city. So let's add a city here and add that here, and then run npm npx Prisma generate, and then I'll change this to a find. So instead of create, I'll change it to a find. So find many const users. Okay. So we expect this to fail, right? Because the street. Oh, sorry about that. Okay, I had a delete many in front. Just oh no, now I need to redo this. Okay. Let me quickly redo this since we are not time constrained, as Nico told me. All right. Let me regenerate this and create the user here. I can just run that. Okay. And now I'm going to get rid of
like someone in the chat asked if you could bump up the font a little bit.
Oh, I'm sorry. Yes, of course. Is that better?
Waiting to render. Yeah, I think that's better already.
Yeah.
Okay, sorry about that. Now I'm going to add a city here, and I'm going to regenerate the client. And it's a required city. So like we expect all addresses to have a city now. That's what we're saying in the client. Now let's find this old address that didn't have that city. So what happens? We expect an error to occur because we're converting a non-nullable string. We found a null where we expected a non-nullable string. And in Prisma 3.x, whoops, you couldn't do this. Like I couldn't say like default empty string. So yeah, I couldn't just do this. So there's like no way out of this situation. And so we really needed to fix this. And so in Prisma 4, Let me just upgrade it because I think that'll be faster than setting up the rest of this again. At 4, at 4. MEX Prisma generate. And let me try running this time. Yeah, and so you'll see now we're now applying defaults as data is getting pulled out, which allows you to kind of do this on-demand migration. And by the way, that on-demand migration, I don't know if we named it that, but that's also what Mongoose does to do migrations as well. So it's like a pretty common practice for people using MongoDB databases. Yeah, that's all I've got. Yeah, are there any questions? I guess I'll stop sharing and then look at all your pretty faces.
So we did have some questions in the chat, but most of them were not really related to the upgrade process. So I dropped this comment in the chat as well for everybody who has more broader questions about using Prisma, for example, about full text search or raw queries with Mongo. Please ask those questions in our main repo via GitHub discussions instead. So we're monitoring the questions there and trying to answer everybody. And there was only one question from Joao here in the end about any breaking changes. And apparently they're new to Prisma, wondering whether they should get started with 3 or 4. I think the answer to that is pretty straightforward. If you're new to Prisma, then I think it's best to start with the most recent version. And in this case, that's what we released last week with Prisma 4 indeed. And yeah, that's it. We don't have
maybe Nico, one other thought, Nico. I think also the incentive should be high, right, to upgrade to 4. And I hope we have kind of demonstrated how easy it is, because we have a bunch of super cool things lined up that are coming later this summer, and they will all be only in Prisma 4.
Yeah, so make sure that you upgrade, otherwise you're going to miss out on the good stuff, or you'll have to deal with all of the breaking changes a little bit later. So just like get the chores out of the way as soon as possible, I guess.
Yes.
All right, Frederick, Tom, Matt, it was a pleasure to have you here today. Thank you so much for joining me. And everybody else, we'll see you here in 2 weeks again for What's New in Prisma. Thanks, everybody. Bye.
Thanks everyone.
Thank you.
Bye-bye.